tangent length from an external point are equal. This is a theorem. So we just see we're going to prove this theorem. Now let us see how to do it. So tangent from an external point are equal. Now before we go ahead, let us know what is the length of the tangent. What do you understand by length of the tangent? So length of a tangent is the length of the segment of the tangent between the point on the tangent and the point of contact with the circle is called the length of the tangent from the point to the circle. Now let us draw a figure to understand it. This is a circle. This is the tangent. We take a point here. This is a point of contact. And take a point here. This is P. Okay. This distance from P to Q, this distance is called as a tangent length. Hope I am clear. What do you understand by tangent length or length? So when you see this, so this is the length of the tangent from the point of contact to a point on the tangent. Now let us go for proof of this. It's a theorem. So because it's a theorem, first there is an order in which this theorem has to be proved. When you're proving it, we have to write all the steps. So I'm doing in that particular order so that make a note of these are the steps which must be there. Now start with the first thing, we start with the theorem. So whenever you are trying to prove a theorem, we need to write the statement of the theorem. So first statement is the lengths of two tangents drawn from an external point to a circle are equal. We are having two tangents and we are drawing it to the circle. So the tangent lengths are equal. This is a circle. This is a point outside the circle. External point it is. We draw one tangent. This is a point of contact. We draw another tangent. This is a point of contact. Okay. This is the center of the circle. Now, what is given? You see here, AP and AQ are two tangents from an external point A to the circle with center O and radius R. Okay, COR means circle with center O and radius R. So A is an AP and AQ. These are the two tangents. Okay, from an external point. This is what is given. Now let us see. What you have to prove? You have to prove that AP and AQ both are equal. Now to prove this, we will have to make some modification which we call as construction. So we first join these two lines. Join OP. OP. Okay. We have joined OA, OQ, OP. We have joined all three sides, that is OA, OP and OQ. This is a part of the construction. So once you do this, so we prove these two triangles are congruent. Once you prove these two triangles are congruent, we can say that this length and this length are equal. So that is the concept we are trying to use, congruency concepts. Now to prove, we know that the radius are perpendicular to the tangent through the point of contact. That means this is the radius and this is the tangent. So at this point of contact, this radius should be perpendicular. So because it's perpendicular, OP is perpendicular to AP and OQ is perpendicular to AQ. Because they are perpendicular, this implies that angle OPA and OQA both are equal to 90 degrees. So 90 degrees it is, 90 to 900 it has become by mistake. Now, so this is your figure. Now, in the right triangle OPA and OQA, that means OPA and OQA, these two right triangle, OP is equal to OQ is equal to the radius. OPA, this angle is equal to this angle, both equal to 90 degrees. And OA is common to both these triangles. So right angle, okay, this is 90 degrees, this side is equal and this is also equal. So this, if you see here, this is a hypotenuse and this is a radius which is so, and this is 90. So these two triangles are congruent. By which rule? By RHS correct. Right angle, hypotenuse and side. Right angle, hypotenuse and this side are equal. So these two triangles are congruent. So we can say that AP is equal to AQ. Why? They are the congruent parts of congruent triangle. Clear? So these two sides are equal. This is what we have to prove. Hope you understood. And did you like my way of explanation? If you so, please like, subscribe for the channel and click the bell icon. Thank you.